Welcome to the first of many videos that you will view this year as you proceed through the geometry course. I would ask you to remember throughout this video and all of the videos that watching a video for the purpose of learning is much different than watching a video for the purpose of entertainment. If at any point in the video you get to a place where you don't understand, make sure you take the time to pause, stop, rewind, and listen to the explanation again. If after listening again you still don't understand, you want to make sure that you jot down your question in the margin of your notes, maybe even alongside the time in the video that your question occurred, so that you can remember to ask your questions and get your concerns addressed when you come back to class. All right, so these are some basic terms and words that we're hoping that you're pulling back with you and remembering from your time in previous math classes, and we just want to make sure that everybody's on solid ground and strong footing as we move forward in the class. So remember that an acute angle is any angle whose measure is between 0 and 90. I remember acute angle because I think a teeny tiny cutie little angle, measure between 0 and 90. The next one, adjacent angles. The definition, if you look at the words, seems fairly complicated. What this really means, or how I think about this, is that word adjacent means next door. So these two angles live next door to each other. Angle 1 lives next door or adjacent to angle 2 in the picture. An angle, remember, it just consists of two different rays that have the same initial point. So in the picture, the initial point that both rays have is point B. Some different names for that angle. You could call it angle ABC. You could call it angle CBA. Angle B, just the vertex. Or even with a number, angle 1. And the symbol that we use for the word angle is just that little angle symbol. An angle bisector is any ray that will divide an angle into two adjacent angles that are congruent. I'm going to focus a little bit on the picture here. In this diagram, we've marked each of these angles with one arc, and that's an indication to us as the reader that those two angles are indeed congruent, are indeed equal in measure to each other. So the same arc in each angle means the same measure in each angle. Speaking of arcs, what is an arc? An arc is exactly what it sounds like. It's part of the circumference of a circle. So part of the distance around that outside of the circle. We'll focus on that more in the spring semester when we talk about circles. Bisector is exactly what it sounds like. A bisector is something that splits something into two equal parts. Now we might be talking about line segments, and it might split a line segment into two equal parts. And the way that we're going to acknowledge that those parts are equal on any line segment is by using these hash marks. And those two green hash marks are an indicator to us as the viewer that those two segments in the picture are indeed congruent. Might be an angle bisector. And again, because we're splitting that angle into two equal parts, we're going to end up with two equal angles. And the way that we're going to demonstrate in the picture that those two angles are equal is by marking them each with one arc. The definition for circle sounds fancy, but the picture is easy. It's a set of points equidistant or at a fixed distance from a given point. So in other words, every single one of those blue points on my circle is at that same fixed distance from the red point in the center. Collinear, if you look at the word collinear, you see the word line within the word collinear. Collinear points are any points that lie on the same straight line. So in this picture, point A, point B, and point C are collinear because they all lie on the same line. Complementary angles, remember from middle school, are any two angles whose sum is 90 degrees. This might be silly, but I'm going to give you a silly way to remember. Complementary, I see the number 90 in there. That goes with 90 degrees. Another one I've heard kids say is that they will compliment a 90-year-old lady. So however you remember, that's up to you, but you need to remember that complementary angles sum to 90 degrees. Congruent means having the same size and shape, and when we talk congruent, we might be referring to line segments, we might be referring to angles, to triangles, or to some other kind of polygon. But any two things that are congruent have both the same size and the same shape. Congruent angles are then angles that have the same measure. So in this picture, both of these angles have a measure of 80 degrees. They are therefore congruent. So we say angle 1 is congruent to angle 2. Remember too from your middle school days that the symbol for congruent is the equal sign with the little squiggle above it. Congruent segments are segments that have the same length or have the same measure. So in the picture here, they both have a length of 5, making line segment AB congruent to line segment CD. Coplanar points are any points that lie on the same plane. So in the picture here, points A, B, and C lie on the same plane. I think about a plane as a flat sheet of paper. They all lie on that same flat sheet of paper, making those points collinear. The distance between 2 points is quite simply the length of the line segment that joins those 2 points. So the distance between the endpoints in the picture here, 7 units. Equals means having the same measure. That's fairly self-explanatory. Could refer to line segments as it did in the picture, or maybe to angles, which isn't shown here. But equal means having the same measure. Equidistant, on the other hand, means having the same distance from 2 or more things. So in this particular picture, the way this diagram is drawn, point X and point Z are equidistant from point Y. How come? Well, point X is 5 units from point Y. Point Z is 5 units from point Y, making these two distances equal, and therefore the points are equidistant from point Y. Intersect means to have one or more points in common. So the point of intersection, the point that they have in common in that picture, is that purple point. Length, quite simply, is the distance from the end of something to the other. So the length of this line segment is going to be the distance from one endpoint to the other. A line is a geometrical object that is infinitely long in opposite directions. I'm going to focus a little bit on how we name a line. You can name a line by using any 2 points on that line. So for instance, line AB, line AC, and line BC all name the same line. You can also name a line by using a lowercase letter. In this particular case, they've used this lowercase letter L. Mathematicians aren't always necessarily real original, so we tend to use L to represent lines. A linear pair of angles are 2 adjacent angles formed by intersecting lines. Remember that that word adjacent means next door neighbors. So this linear pair here is going to be 1 and 2. Together, they lie on that same straight purple line. Linear pair of angles, interestingly enough, is always supplementary. And we'll talk about supplementary later in the video. The measure of an angle is just the number of degrees or the size in the angle. So in this particular case, the measure of angle A is 80 degrees. Notice that when I write that, I use the lowercase m to represent measure. So measure of angle A is equal to 80 degrees. All right, up at the top of the next page, midpoint. Midpoint, it's exactly what it seems like. It's the middle. It's the point that splits a segment into 2 equal parts. So in this particular case, midpoint is marked by M. And again, this is a case of mathematicians not being terribly original here. I know that that guy is the midpoint because these 2 line segments are equal. I know they're equal because I'm going to mark them with the same hash mark. An obtuse angle is any angle whose measure is between 90 and 180 degrees, and you've seen and heard that a lot before, so that's as much as I'm going to say about that one. Opposite rays, again, it's a lot like what it sounds like. So there's a ray going in that direction. Here's a ray going in exactly the opposite direction. The green ray and the red ray are going to be opposite rays. Parallel lines, there's a fancy formal definition there. I think about parallel lines as having the whole railroad tracks idea going on. The symbol that we're going to use to represent the word parallel this year is that little railroad track symbol. Perpendicular are 2 lines that intersect to form right angles. How are we going to know when 2 things are perpendicular? We're going to mark them with a right angle in the picture. The symbol that we're going to use to represent perpendicular is the upside down T. So anytime you see that upside down T, you're going to think to yourself, perpendicular. A perpendicular bisector is kind of a complicated, fancy term because there's a lot going on. The word perpendicular tells us there's going to be some right angles formed. So if I go over here to the picture, there's some right angles. The word bisector tells us some things are going to have to be cut in pieces, or sorry, cut in equal pieces. So my equal pieces there are the segments that I just marked with the blue hash mark. Notice that a perpendicular bisector can be a line, could be a line segment, could be a ray, anything that forms right angles because of the word perpendicular and cuts that line segment into two equal parts due to the word bisector. Plane I already talked about a little bit previously in the video. That, again, I think about like a flat sheet of paper. So the ceiling, the floor in the classroom, all of those things would be an example of a plane, the top of the desk. You're going to name a plane by using 3 letters. So any 3 letters on the plane can be used to name that plane. So notice that in the picture that I've drawn here, we might call that plane ABC. We might call it plane BCD. Both of those refer to exactly the same plane. So that can be a little bit complicated in that one geometric figure can have multiple names. A point is a precise location in space, and you name a point by using a capital letter. Radius of a circle we'll talk more about, especially when we get to the spring, but a little bit in this unit too. It's just a line segment that joins the center of a circle with any point on the circle. And again, that should be a term that you're really familiar with from middle school. You've used that a lot. Ray is any part of a line that consists of an initial point and all of the points on the line that extend in one direction. So in this particular case here, we've got this ray whose initial point is A. So this ray starts at point A, passes through point B, passes through point C, passes through point D. And I know you've heard this before, but I want to make sure that we are all on the same page here. Make sure that when you name a ray, you name the end point first, any point on that ray second. So when we call this ray AB or ray AC or ray AD, those all refer to the same ray. Again, different names, but same geometric figure. A right angle, you know, is any angle whose measure is equal to 90 degrees. And again, the way that we are going to demonstrate or to show or to indicate in our diagrams and pictures this year that something is a right angle is with that little box in the corner. All right, up to the top of the last page. Segment is just a short name for line segment, and that's any part of a line that consists of 2 endpoints as well as all points that are in between those 2 endpoints. So in my picture here, A and B are the endpoints. The line segment is line segment AB or line segment BA. They both refer to the same line segment. The next definition, segment bisector. Again, you hear that word bisector, meaning to cut into 2 equal pieces. What it is that we're cutting into 2 equal pieces is a line segment. And again, in that diagram, we're going to indicate that those segments are congruent or equal pieces by putting a hash mark in each one. Skew is, I think, the hardest one to define. I'm going to say the formal geometric definition is that there are any 2 lines that do not intersect but are not coplanar. I'm going to change that to say do not intersect and are not parallel. So skew lines are any lines that don't intersect but don't fit our railroad track definition of parallel. So in the box or in the picture that I've drawn here, if you think about this as a 3-dimensional shape, that red line in the back and that blue line in the front, they're never going to intersect, but we wouldn't call them parallel because they don't have the whole railroad track shape going on. The name that we have come up with these is skew. So skew, don't intersect, not parallel. A straight angle is exactly what it sounds like, looks like a straight line, has a degree measure equal to 180 degrees. Supplementary angles, you should remember from middle school. I've seen kids do this with the supplementary and make the 180 out of it. Any 2 angles whose measure together is 180 degrees. An undefined term is a word that we want to talk about, but we can't really formally define. We can't really give a good definition to it. Words like points, lines in planes. Vertex of an angle is the point where the two rays intersect to form that angle. So in this case, the vertex is going to be that red point right there. And then vertical angles, a fancy formal definition is that they're non-adjacent, in other words, not neighboring angles that are formed when two lines intersect. So in this particular case, any two that aren't neighbors would be 1 and 2. You should remember too from middle school that vertical angles have equal measure. So I've indicated here that their measures are equal. And because their measures are equal, we know that the angles have to be congruent. A second pair of vertical angles in that picture would be the blue angles 3 and 4. And notice that I have marked those with 2 arcs each, indicating that they are congruent to each other, but not necessarily congruent to the 2 angles marked with 1 arc, angles 1 and 2. All right, so there is your first geometry video. I'm hoping that this will be the very longest one of the year. If you did have questions, please do take time to stop the video, rewind the video, rewatch just the part that you had a question about. And if you still have questions, please make a note down in the margin at the bottom of page 6 would be a great place so that I can address your questions and concerns when you return to class.